Hey guys, today we're going to talk about the law of cosines. This is another method for solving triangles, and unfortunately it's more difficult and a lot lengthier than the law of sines that you probably have already learned. It's also not as useful as the law of sines. The law of sines is used for pretty much any triangle, and it can really help you solve triangles fast. But the law of cosines does have its place. It's used when you are given two side measurements along with an angle in between them, or all three side lengths. So what that means is that you could get side C and B, and you'd have to get angle A. You have to get what we call the included angle. I'll write that. So two sides plus their included angle. And the included angle is just the angle that will be in between them. So let me ask you, if I give you sides C and A, what angle would we have to be given to use the law of cosines? We'd have to be given angle B because we have C and we have A. What angle is in between that? Angle B. And remember, when I say we have C and A, I'm saying we have two side C and side A. And I'm asking what angle. And then finally, what if I have give you side A and side B? What angle would we have to use the law of cosines? We'd have to have angle C. And then obviously the other situation is when you're given all three side lengths. So if I have little a, little b, and little c, I can also use the law of cosines. And another unique thing about the law of cosines is that there's actually three formulas, but they're all the same. They all do the same thing. And so what it says is a squared. So remember that lowercase means the side length. A squared equals b squared plus c squared minus 2bc cosine of a. So the way I remember this is that the one on the left hand side, whichever one it is, does not appear again until you use its angle at the cosine. The rest of it just follows the order b squared plus c squared minus 2 bc cosine of a. So, and then it also starts like the Pythagorean theorem, where we have a squared equals b squared plus c squared, or well, it's usually c squared equals a squared plus b squared, but my point is just that it starts similarly. And then, so again, if we use the next one, we see b squared equals a squared plus c squared minus 2ac. So we're repeating the same letters again, and then finally at the end we see the letter that we started with, but we're using its angle. And then it's a very similar formula for c squared. So really you just need to memorize one of these, and then once you start working through them, you're going to realize it's pretty simple to figure out which one you need, because it's going to be the only one that you can use based on what you're given. Remember that you always have to only have one variable in the problem, so whichever one you could fill out and only leave one variable, that's the one you need to use. So let's take a look at which one we should use for these examples. Solve each triangle. So somehow we need to figure out how to solve this triangle, and we don't have any angles. But if we were given one angle, I know I could use the law of sines. So I just need to somehow find what that first angle is, and I can use my law of cosines. I'm going to set the c squared equal to the largest term, and I'm going to solve for that. So I'm going to say 15 squared equals, well, a squared and b squared. It doesn't really matter which one I use, but I have to add them up. So I'm going to do 12 squared plus 13 squared. And then I know the formula said minus 2, but what if I forget what letters they were? Well, I know that it's going to be the same numbers that I used here. So I'm not going to ever repeat this number again. So it's going to be the same two numbers, 12 and 13. So minus 2 times 12 times 13. And then I remember, well, that's when I take the cosine. But what angle do I take the cosine of? Oh yeah, it's whatever angle was opposite here. So it's going to be this angle. I'll name it C for this one. It doesn't really matter what it is. So we'll say C for now. And now I'm going to somehow solve this. So 15 squared, that's 225, equals 144, 12 squared, plus 169, 13 squared, minus, let me do this really quick in a calculator, 24 times 13, minus 312 cosine of C still. So I still need to figure out what C is. Alright, well, I'm going to do some subtraction. Let's, we'll combine 144 and 169 first. That gives me 313, so I'm now at 225 equals 313 minus 312 cosine of C. Getting closer where I need to be. I'm going to subtract 313 from both sides. See what I get here. 225 minus 313. I get negative 88. Okay, so negative 88 equals negative 312 cosine of c. Now I just need to divide to get the cosine of c by itself. So divided by 312 divided by negative 312. So negative 88 divided by negative 312 equals a positive 0.28. So 0.28 equals the cosine of c. So now we need to think, well, what do we do when we get to this point? Oh yeah, that's when we take the inverse of both sides to get c by itself. So I'll take cosine inverse of both sides. So cosine inverse. And then what cosine inverse does, it allows these to cancel out. So I'm left with just c on the right hand side. And I'm left with cosine inverse of 0.28. And now I'm going to plug that into my calculator. Cosine inverse of 0.282. And I get 73.6. C equals, I'll round to 2 decimal places, 73.62 degrees. So that's this angle right here. So that's how we use the law of cosines to help us. 73.62. And as you can see, it's a lot more drawn out and a little bit more difficult than the law of sines. But in this case, we couldn't use the law of sines up to this point. Well, now to solve the rest of the triangle, we can. So let's try to remember and how to use the law of sines. And what the law of sines says is that sine A, or well, that was supposed to be capital because we usually capitalize the angles. I should have done that over here. Doesn't really matter. Divided by side length A equals sine of B, angle B, divided by side length B, which equals sine of C, divided by side length C. Okay, so now we see that we're given one of the angles, one of the full ratios. We have both the angle and its side length. So we'll just make that our ratio. So sine 73.62 divided by its corresponding side length, which is 15. Set it equal to, well, sine. Well, now we don't know any of the other angles. But let's say we want to solve for this one. I'll call it B, sine B. What's its corresponding side length? Well, it's the one directly across from it, which is 12. So I'm going to put 12 here. And now, let me give us some space to solve it. I need to solve for B, and so I cross multiply. So I multiply these two, and I set them equal to multiplying these two of the diagonals. So it'll be 12 times the sine of 73.62 equals 15 times the sine of B. Then to get sine of B by itself, I will divide by 15. So right now I have sine B equals all of this stuff here. And again, it's going to be the same thing we had to do with the cosine. I have to somehow get the B by itself, and so I take not cosine inverse this time, but sine inverse of both sides. So let me draw an arrow here. I will get B equals sine inverse of that entire thing. So 12 sine 73.62 divided by 15. Let's see what that gives us. So sine inverse of 12 sine 73.62 divided by 15. I get 50.13. So B equals 50.13 for me. So let me put that on our triangle here. So B was right here. That is 50.13. Luckily, we do not have to do the law of sines again. Why do we not have to do it? Let's think about it for a second. If we're given two angles of a triangle, we can find the third by doing some subtraction. So we can say 180, because that's the side lengths of a triangle, have to add up to that. Has to equal the three side lengths added up. So 73.62 plus 50.13 plus x. So I can solve for x by just subtracting both of these to the other side. So minus 50.13 and minus 73.62. So let me figure that out here. 180 minus 73.62. That'll give me, for that I get 106.38. Then from there, I'm just going to subtract my 50.13. I can just do this one by hand pretty quick. I'll get 5, 2, 6, 10, 5, 56.25 degrees. 56.25 degrees. So now I have found all of my angles and all of my side lengths, so the triangle is solved. I use law of cosines at the beginning, and then I use law of sines at the end to solve everything else. So that's one way to use the law of cosines. Now let's look at the other way. And in this one, I'm not going to solve the whole triangle. I'm just going to use the law of cosines to help get me started. Now this is the other situation we talked about, where we're given two side lengths here, 10 and 15, and then we're given their included angle here. And so now we need to think, how can we use the law of cosines here? Well, remember that the law of cosines on the right hand side has two variables squared minus 2 times the same two variables, and then the cosine of some other variable, and that equals a third side length squared. So the ones on the right hand side, the side lengths on the right hand side, have to be the ones that were given. So I know that this one and this one need to be on the right hand side, which leaves me with this one, which I will call side B, must be on the left hand side. So I must have b squared equals, and then I know it's a squared plus c squared, because those are the only two other angles. So it'll be 10 squared plus 15 squared. And then I know it's minus 2, and even if I forget, I can still think, well, it has to be, I know it repeats these two. I know it repeats the variables, so it'll be minus 2 times 10 times 15. And then I also know it's cosine, but what if I forget what angle? Well, it has to be the only angle I have. It's always going to be that included angle next. So that's going to be cosine of 40. And this one is actually easier to solve than the first one we did when we're given 3 side lengths, because there's no inverse trig to do. We literally just need to plug this in and figure out what b squared is. So let's start with b squared. I'll do it as much as I can by hand. So 100, 10 squared plus 15 squared gives us 225. Minus, well, 2 times 10 is 20 times 15. 20 times 15 is 300. Minus 300 cosine of 40. Alright, and so now I'll get b squared equals 100 plus 225 is 325 minus 300 cosine of 40. And I think that's as far as I'm going to try to go by hand. But now I can take the square root of both sides, so I can just get to b. So I'm going to do that here. And I'll get b equals the square root of the whole thing of 325 minus 300 cosine of 40. So let's see what I get in my calculator. So square root of 325 minus 300 times cosine of 40. And remember again that you're in degree mode. And I get 9.76. So that is the side length of b. And once I have found this, I could do law of sines to finish out the triangle. So law of cosines always serves as a good starting point to a triangle. It's usually not going to be the be all end all. It's not going to solve the triangle for you, but it can get you started and then allow you to use the easier rules that you may be more comfortable with, such as law of sines. Hope this was able to help. Let me know if you have any questions. Thanks for watching.